when you interact with the kernel itself should be very lightweight, right? We want the library itself to just be super easy to pip install, hopefully very minimal dependencies, same as the NuGet package for C#. But the idea is that you can instantiate many kernel instances if you want. And when you do, right, the kernel, you add a model to it. So maybe let me zoom in if you can't see. You add let's say a text completion model. Later on, we'll show off like embeddings, or if you want to do image generation, you can as well. Next is, right, so we talk about semantic skills, and semantic skills are more or less functions that you define with a prompt and a config. And that prompt is, something, let's say, if you're writing a joke function as a part of a fun skill, right? It's like, okay, write me a joke. And you see here, we have this sort of syntax. We have a simple but specialized like prompt templating language to be able to express things like variables and things inside the prompt. And then I'll go into that in a bit. But with a prompt, right, you define what you want the AI to do, and then you provide the config as well. So that config is the parameters for that model, things like tokens, temperature, top P. But so once you have all that, similar sort of thing, you instantiate the kernel, you provide it, or you register the service that you want it to have, and then, right, in this case, we're importing from disk, or we're importing these files, or we're getting the fun functions from the fun skill, right, and we're pulling out the joke function in particular. This function takes in a string parameter, and it can give you a result back. One thing to call out here is that unlike some other frameworks, right, the kernel is asynchronous by design from the get-go. So you can also call these functions asynchronously. Okay, so next in our series is, right, you could do the very same sort of thing. Maybe you want to do it in a less verbose way. You don't want to manage multiple files. There are certainly good reasons to do that. Things like version control and things like that. But you could also just define these semantic functions inline as well. So if you have a prompt, right, you can just do a create semantic function with the prompt and then the parameters as well. And again, same thing, you could use that function and call it directly on some piece of text. So if I wanted to create a TLDR function, right, I would just create it like this, inline, and then call it on some text. Okay, so I'll pause here. I'll take a look at chat. Rcast, can you use semantic kernel to have users call or trigger APIs using natural language? Yes, actually. I mean, that's one of the beauties. This is where you mix in semantic and native code. And let me kind of just really show the prompt templating language to kind of highlight how to do that. So I mentioned before, right, the prompt templating language allows you to set variables inside, and that variable is expressed as what we call just context, a context variable. So you could just do substitution, like hello, which effectively a dictionary, where it's like you have a name, key value, you just substitute that in directly into the prompt, and that's pretty standard across templating languages. But one of the interesting things that's probably more unique to the kernel is that you can actually, even within the prompt, call functions, right? Those functions can be native or semantic. So it's like the weather today is, weather get forecast, right? This is a weather skill, and you're calling the get forecast function, right? However you implement it, it could be calling some external API. That function might take some input, like, I don't know, a city or zip code or whatever. But the idea is that you can call functions inside your prompts, and this can get pretty interesting, right? If you're, calling many functions within your prompts, all of them have to, execute asynchronously, and you construct a very rich prompt that you send to the AI. Yeah. So one more example here, right? If you, let's say, wanted to use MS Graph, right? You could fill in a prompt that looks like, hey, my name is this, my email is this, my hobbies are this, and yeah, and you would fill it in. Ashish, go ahead.
Yep. There is one more question, and then I can ask. Go ahead, and I'll also. I have a question. I think Nikki asked, can I give low token count in hope to reduce cost?
So the answer is, of course. I mean, you can send to the API whatever you want. The answer, or the obvious thing, is that the quality will suffer if you don't provide a big enough or rich enough prompt, and that often means, yes, like more tokens are being sent to the model. Maybe you can get by with using a more powerful model, but at that point, right, your API cost is already higher compared to, let's say, using like GPT-3.5 Turbo or whatever. So this is something that you have to play around with. You have to experiment, but it's a good question.
Mark, I know you've raised your hand. I'll just go ahead, and then you can go next. Alex, as you mentioned, you can call a lot of different types of functions here, right? And I do understand, like maybe you're asking a question and you're, relying on the semantic kernel to reach out to different connectors, maybe, if I may, right? And figure out which is going to be the perfect answer, right? So that once you're doing that orchestration, and you're also giving that NL to, like, you can design everything through using natural language, right? So once you add, let's say, multimodal, right? And if I have image Florence, let's say some form of, image-based embeddings, and as well as NL-based embedding, right? And you're very cool with like writing these different functions, right? Do you think we just with semantic kernel, without the introduction of all these together, different models for different embeddings, we can devise a way where we don't need multimodal, like we just take two different models, BERT as well as, let's say, YOLO, right? Object detection, and do that. What are your thoughts on that?
Yeah, so I'll at least highlight, or to pull up this notebook here, where right now we've showed off OpenAI, but you could use honestly any model within the kernel and build skills against them. In this case, I'm showing off, right? Actually, you could pull in any Hugging Face model and do the same sort of things, right? You can, if you, let's say, wanted to run this locally, right? You don't want it to incur cost by using a cloud API, right? This could be a path for you to say, okay, I'm going to instantiate one version of the kernel that can do a cheaper skill, right? Using a cheaper model that I can run locally, and maybe only use GPT-4 for the more like complex thing. When you want to do something that involves multimodal, right? This is where I don't have in Python, but I'll show it in .NET, where you can for sure just call, and this is like pretty early, like where we do support some of this, but right, calling a model like DALL-E, right, within the kernel itself is, also works like very well too. So the idea is that, right, the kernel itself, or at least the user, should not have to think like, okay, it's one SDK, but then I have to, like, for a different model type, I have to go fetch a different SDK. If anything, right, if there are, beloved SDKs that you like, right, it should just be actually expressed as a semantic kernel skill or native function or sort of things. As you saw with the Hugging Face example, there's no problem for us to say, like, what is it? To just like import or install external libraries, right, if you want, and just make use of those within the kernel. But again, the core idea is that the kernel will do the orchestration piece for you.
That's the coolest part, I would say, really, and making it asynchronous for sure. Thanks, Alex. Mark, yeah, Mark is from my team as well. Mark, go ahead.
Thanks, Ashish. Yeah, and so I've just been starting to read up on semantic kernel a bit, but so you showed the example of using, calling a function within the prompt. Are you able to have users like communicate their intent to perform an API? Like, let's say that they wanted to open a ServiceNow ticket or translate a document, something like that. Is that all done through the connectors, or how is that performed?
Yeah. Okay. So let me walk through this notebook. Actually, with the Python version, because I'm assuming probably more people here are comfortable with Python. Okay. So this is where, right, I would say if you want to incorporate user inputs, you would for sure want to make use of things like context variables, as well as potentially memory. So memory is what I'll look after this. But a context variable, just think of it like a dictionary, right? Key value store. But in this use case, or in this notebook, I show off how you can simulate a chat experience, just by creating semantic functions and using our templating language, right? So in this case, right, this is the prompt. It includes a history as well as user input. So the function gets created, cool. You instantiate or you create some history, you create some context. And that context, you initialize the variables however you want, right? At the beginning of the conversation, the history is blank. The first response or first user, right, interaction is like, okay, what this user input is. And then you just call that function, right? Invoke async, and context, is the context variable, or context object. So now putting it all together, right? You can now sort of create this chat function that, again, takes in the user input, calls it, and then updates that history, right, with the history of the conversation so far. And with that, right, you'd be able to, it's like, I'm looking for book suggestions. You say what you like. I wish I showed the output of these cells here, but you all can run it yourself. But that's the idea, right? The idea is that if you are, let's say, talking with a customer and they have, like ServiceNow tickets or in a chatbot setting, right? You are collecting user data or user inputs, and you could store that naively. You could store that as context right here, but perhaps more interestingly is to use memory. Okay, so memory is another big concept in semantic kernel, and again, the key idea is that memory is very closely tied with embeddings, and embeddings are effectively a compressed representation of data. That data can be anything: text, images, audio, and it turns that data into a vector of floats, and that vector of floats, the size of that vector is determined by whatever the embedding model is. In this case, the ADA model will produce some fixed size vector, and the importance of that, like why you should care about that, is once you have embeddings, you can now do vector operations with those embeddings, and that allows you to do things like, okay, in vector space, how close in distance is one vector to another. So if you embedded all these documents, right, all these, let's say even like conversations, right, you can pull up from the memory using some similarity search and distance measure, like cosine similarity. You could pull out the relevant piece, relevant chunk, and then pass that into your prompt, pass that into your skill, and then call that skill with that, right? And hopefully that's a much better response than nothing. So that memory, right? A big piece of that is what memory store are you using. So in this example, you can just use a volatile memory store, just your application's own memory, or your computer's RAM, right? We also support things like SQLite, Cosmos if you want. But probably what's become very hot recently is these vector databases, and we support those as well. The Microsoft first-party solution or answer will be Azure Cognitive Search, of which we'll also, or we today have support for, but that's in private preview. It's rolling out later on. Okay, so it's kind of finished this point is there is a core skill that we have, and the core skill is stuff that is part of the built into the kernel. We expect people to make use of them probably regularly, and this one is a text memory skill, of which that text memory skill exposes a recall native function, and its job is to just do what I was describing, fetching the most similar document based off of the embedding. So showing off here, right? When you're creating memories, you are saving that information, and that is calling the embedding model, right? To store these vectors. So that's done by the save information async. And when you're actually doing the search, right, that's calling the kernel.memory search async. And that's effectively what this recall function is doing. It's calling this search on your input. So you can see how that's all put together inside this prompt, right? Here we have some context variables of facts, right? That those facts are like, what is my name? So in this case, like information about me, it's like, what is my name? And then the recall function grabs the memory based off this piece of text and puts it inside the prompt for you to use, for the AI to use. That enriches your chat experience by allowing you to both store memories and also recall them as you see fit. Yeah, you could, and it's not just in a chat experience, right? You could embed full documents as well. So right here, you could add references if your documents are organized in a certain way. You can give them a collection name and store them accordingly, like that.
Perfect. Alex, we do have 6 minutes left and 3 more questions. The first one is by Nikki again. May I know how big the vectors uploads can be?
Yeah, it can be any size. It really just depends on the embedding model.
Yes, like if just Nikki, if it depends. If it's GPT-4, let's say, it may have more number of dimensions, right? But it depends on the model. Okay.
So I can just read the next one. So how does it scale to multi-user environment? It's a great question. I would say it depends how you want to implement it. But you can imagine each user could have their own memory. There could be some global memory as well that all users have access to. Again, depends how you want to implement. Are docs stored as graph? Not exactly sure what that means. If you mean like a graph data structure, no. Docs are just stored as like the vector, as well as potentially the reference to that doc, right? The entire regular piece of text. So think of it as like just like the embedding vector is a fuzzy way to do a lookup to this data store.